Today, we're beginning Unit 4, Quadratic Functions, and we are starting Lesson 1. So you should have with you this booklet, Unit 4, Quadratic Function. There are 3 lessons in this booklet. The first lesson, Characteristics of Quadratic Functions, which we begin today. And there are 2 sections to Lesson 1. The next is Lesson 2, Applications of Quadratic Functions, and finally, Systems of Equations. So if you now look into your inside cover of this booklet, you see a list of outcomes that will be covered in this unit. You may want to take some time to go through each of these outcomes to check out the ones you feel confident about. So you may know some of these, you may not. But if you don't, you're in the right place because that's what this unit is about. So then we'll begin the first part, Lesson 1, Characteristics of Quadratic Function. And our goal is to describe characteristics of quadratic function, looking at its shape, its vertex, leading coefficient, end behavior, y-intercept, y and x-intercepts, the range, and also we look at domain. The first part, we'll be looking at quadratic function when you're given the graph. So your graph is given and you're asked to describe it in terms of its shape, its vertex, leading coefficient, end behavior, y-intercept, x-intercept, and the range. So that's the first part. The second part, we were looking at the same quadratic function, but in the second part, you are not given the graph, you're given the equation, and you have to describe it. Now, for these lessons, you will need your graphing calculator, or if you're using Desmos, so either one of these you will need. So your graphing calculator or Desmos. Also, I will recommend that you have with you this handout on calculator instructions. So there are 2 sides to this handout. And if you're using Desmos, handout on how to display data and find a line of best fit using Desmos. So in this case, we've completed line of best fit. We're going on to quadratic functions. There's slight variation, but it's the same process. Now you may ask, what's a quadratic function? Now, a quadratic function is any function that has this, so a quadratic function, I'll write it here. Now, previously, we completed the equation of a straight line. Now, quadratic function has this form, y equal to ax squared plus bx plus c, where a is not equal to 0, and b and c are numbers. It could be 0, 0 is a number. Now, you may say, what's a quadratic function now? In reality, this is what it looks like. It's like it's a parabolic shape. So for example, this fountain water goes up and comes down back. It takes this is a parabolic shape. And this has an equation of this form, y equal to ax squared plus bx plus c. Or in bridges, you'll see these parabolic shape. Here you have contact lens. These are examples of quadratic functions. And you have the parabolic shape, so it's a parabola. And you notice so it's often described as a cup shape or inverted cup shape. So it's like a cup, except it's inverted. In this case, it's a cup opening up. You may also see the old-fashioned satellite dish. This also has a quadratic function in this equation. Now, here we have using your graphing calculator to analyze functions. To do any one of these, you want to see what it looks like. If it's a graph that has this shape, and it doesn't matter going up. This we'll say is a quadratic. So if you were to put any one of these equations into your calculator and you end up with a shape that looks like this, it's a quadratic function. Also, it could be going, guess it might be going so downwards. So it doesn't have to be always going up, it could be going down. So these are examples. In this case here, it's a y going to be equal to minus ax squared plus bx plus c. And in this case, be plus, not minus. So if it's going up, it's a positive graph. If it's going down, it have a negative ax squared plus bx plus c. So we'll enter these into our calculator, and if it looks like in any one of these shapes, it will be quadratic. Now, you can use Desmos, or you could use your graphing calculator. It doesn't matter. I'll try both. So I'll use Desmos, the first one. And in Desmos, once I have Desmos, by the way, I'm just going to show you the whole process. I just open Desmos, and I enter my equation y equals 0.02. Now x there, and you're going to press, receive a to the power 2, press that, and that will give you your square sign. Next, we type in minus 3. Okay, then we go back here. We want to center a graph. We pinch, and there's a graph. One of the things you like to do in Desmos is like you want to get your origin in view. So now this graph looks very similar to the one up here. So this is a quadratic. Notice this graph actually almost goes through the origin, but it's not. We learn about that. This is the vertex. So it crosses the y-axis at -3. So it's your vertex. So we can say safely that the first one is a quadratic. Now, if you were to use your graphing calculator, I'll zoom out, see. With your graphing calculator, you may want to reset your calculator. You go second plus sign and number 7. Enter and go to reset. It clears all your memory. Now to enter your equation, press your Y equal button, and you enter exactly 0.02. Now this is your X button there, and the square button, exploding button is here. You can also use this button here. I'll show you both ways. So let's go, the shortcut is press x squared minus 3, and then press graph. And notice your graph, it's limited because your window is restricted to the domain of -10 to +10, and the range is from -10 to +10. If I want to change my window setting, I will press my window button, and I may want to increase my domain. In fact, so I may include negative maybe 50 here and positive 50 in a graph. There you can see a quadratic function. So the clear quadratic function. Now, go back to my button here. I want to clear it again. I want to show you how to use the exponent button to arrive at the same equation. So 0.02x. Now, if you press this exponent button here, you can go to any exponent here, 2, 3, 4, 5. It's limitless for this one here. But when you press the x squared, you're restricted to the power 2. In our case, it doesn't make any difference. But now I want a power 2. Now, here's the thing you need to do. Once you have that, you have to press the right arrow key to go down and continue. Otherwise, it will continue at the exponent root. So if it's minus 3, that'll give you your equation. Now, what happens if you don't go down? Let's say 0.02x power, press 2. And if I do not press the right arrow, and I want to get to minus 3, I put minus 3 there, it will continue the exponent root. And that's not what we want. So we need to go back, delete, delete, and then go down, minus 3. So be careful when you're using the graphing calculator. Now the next one, it's 2x to the power 3, and you need to use this function, the button. Just clear that. So 2x to the power 3. Then you press downwards plus 1. This graph. Notice now it's very narrow, this graph here, so I may want to restrict my domain. So I go back to my window and I may put maybe negative 10 here, positive 10, what I had initially. And there you can see the graph is doesn't look like any of these two here. That's what we call a cubic function. So we said not. So it's a cubic function. And it will tell you the exponent here, give you a good idea what kind of function it is. Cubic, quadratic, linear. If there's no exponent throughout equation, then it's a linear function. So this would be a cubic function, that's not a quadratic. Now the next one is rather interesting because it looks like a linear function, but it's not really. So if you were to simplify that equation, you'll arrive at a different result. For example, if you were to multiply x times x, you get x negative x squared. So you have to be careful if you were to, first thing you want to do, because the whole thing now becomes negative. So negative x. So let's do it first without the negative there. So x times x is x squared. Then you have x times negative 1 is negative x, 1x. Then we have plus 3x minus 3. Now, the sign is negative out here. So first we simplify all of these. By the way, you don't need to do this, but I'm showing you for those of you who are keen to figure out what's going on here. So now this becomes negative x squared. Now minus 1x plus 3x gives you plus 2x. And this is still minus 3. There's a negative outside, we multiply negative 1 over there. Negative 1 times x squared is negative 1x squared. Negative times a positive, they give you a negative 2x. Negative times a negative give you a positive. So really, this equation is negative x squared minus 2x plus 3. But you don't need to enter, you don't have to change it into this form. So what you do, simply go straight to this equation here and enter it into your calculator. So let's do that and go back to my. So this is not necessarily showing you why it's a quadratic, even before entering that equation into this calculator. Well, let's enter this equation here in negative. Now, be careful, do not use the subtract sign, even though it looks like a subtract there. In your graphing calculator, it wants you to use the one negative in the brackets. So negative, open bracket, x plus 3, close bracket, open bracket, x minus 1, close bracket, and graph. And there it is. It's a quadratic function, and it's a negative. So remember I mentioned to you earlier, if it's going down, it's a negative. So we said this is a quadratic. The next one, 2x minus 1, you suspect that's a straight line. So let's try it out on our graphing calculator. So we've done many of these in the previous unit. So I'll clear that. I have 2x minus 1 in graph. So that's a linear function. It's a straight line. So that's not. So it's a linear. The next one, let's try that one. And by the way, you can do the same thing in Desmos. So negative. Oh, now first of all, I need to go back to my y equal button, clear that. Negative 2x, open bracket, x squared. It's one other thing. Use the shortcut whenever it's to the power 2 here. Plus 1 and graph. And you can see clearly that is not a quadratic. That's another cubic function. And you can tell because 2x times x to the power 2 is 2x cubed. So it's really negative 2x cubed. Negative 2x plus x will be negative. So these are multiplying. Let me go to the next one. So negative 2x times 1 will give you negative 2x. So it's a cubic function. So this is a cubic. The last one, you suspected x times x can be x squared, x times negative 5, negative 5x. So this is really my equation, but it's written in a different form. So I'm predicting this is a quadratic, but let's see what our graph tells us. So to be x, open bracket, x minus 5, close bracket, and graph. As you can clearly see, it's a quadratic. So we're going to say that's a quadratic. Okay. So let me highlight. So this one is quadratic. This is a quadratic going down. And this one's quadratic. So you have two quadratics, one linear and two cubic. Okay, let's move on. In this example, you're given the equation and you're asked to label the y-intercept and the x-intercept. Now, this is where you may want to refer to your instruction sheets. They will give you a reminder how to find the x-intercept and how to find the y-intercept. Also, if you're using Desmos, I'll do an example of how to find the x and the y-intercept on Desmos. It's a matter of touching your intercepting points. So first thing you want to do is to enter this equation into your calculator, and using your calculator, sketch your graph first, and then label the y-intercept and the x-intercept. You see, you need to find these. So let's go ahead. So I'll enter this equation, which is my y equal button, clear. So it's x squared plus 2.25x minus 7.88 graph. Now notice when I graph these, there's 2. It looks like close to intercept 2 here and negative, just beyond -4. And below here, it's around close to just above 8. Or sorry, below 8 and above 7. So I can first of all label 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, -1, -2, 3, -5. 6, 7, 8, 9, 10. So this is around just below 2 here, and just above 4. 1, 2, 3, 4. And it crosses, see, 5, 6, 7 around here. So the graph looks something like this here, goes up. Oops. Parabola going up. But I need to find the x-intercepts and the y-intercept. Now, using your instructions here, we'll find our y-intercept first. It's just how to determine the y-intercept. It says enter your equation, which we already it's already been done. Then we press second, trace, and calc. So second, trace, right? And choose one for value. So we just press enter. And what you want to do, it will show x and type in 0 for the value. So we type in 0, and our y-intercept is -7.88. And you suspect it, right? You would have indicated from here. So this is -7.88. So that's my y-intercept. The x-intercept now, you will follow steps here to find your x-intercept. You already entered the equation in y1. Now in y2, you will enter 0. So we'll have two equations, y equals 0, which goes through the y-axis, x-axis here, y equals 0. And now we need to find two intercepts. So -4 here. Okay. So now we have those done. We're going to go to our instruction sheet. So we completed 1 and 2. Now we go to number 3. So let's find the x-intercept in the negative part of the graph. So where x is negative. So second trace, we go to intersect number 5, press enter. Notice your cursor is flashing here. We want to move it from here. That's our y-intercept. We want to move it to the left. And maybe slightly above, doesn't matter, it could be below. Once it's close to the where this y equals 0 and the function intersect, press enter 2 more times. So 3 times you press enter, and that will give you your first x-intercept, which is -4.1. So y is 0. You should see y equals 0, -4.1. So this here, so I'll indicate that, -4.1 approximately. Or you really could put here 4.2. This is round up. So -4.2. Because you can round up here 4.14. Okay. The next one on the right side here, we say somewhere is closer to 2, but we don't, doesn't look like 2, but it doesn't, I'm not too sure. So let's try it. Second trace, go back to process, go to intersect. Notice it's flashing on the left side. I want to move that cursor to the right side by pressing the right arrow key here. Press the right arrow key continuously until you get closer to the, press enter 3 times. And it's 1.89, which is approximately 1.9. So 1.9. So those are your two intercepts, x-intercepts, I should say. Now, if you write your domain here, so your domain, notice it will be all the values to -infinity. So you can say it's from -infinity going to +infinity. There's no restriction. Or you can write it in for x set of real numbers. Now, in your booklet, you'll see a short form of the, so these are all the same. This is called the interval notation. This is called the set notation. You'll be writing a lot of these when you get into grade 12. Now, the next one, next one I'll show you, by the way, I'll show you both. Let me go back to this one here using Desmos. Now, for those of you who are using the Desmos app, go back, I'm going to change that. And I am going to enter this equation. And so we go y equals, now x squared, x, and this is your power button there, which is a to the power 2 here. Plus 2.5, oh, 2.25 x, oops, minus 7.88. Notice it's really zoomed out. I want to zoom in. Oh, no, I want to. By pressing the home button, I'm going to go down. I'm going to go down here. And I can pinch together. Now, this is my y-intercept, which is exactly as we have here. And to find your x-intercept, you just tap. Sometimes you have to tap twice. 1.899, run to 1.9, and tap again, negative 4.149. So with Desmos, it's a matter of entering your equation, zooming into your graph, make sure you can see your graph, and then tap the intercepts. Later on, we'll find the vertex. The vertex is the point where the graph changes direction. If it's going up, it's the minimum value, and that's by tapping you'll find the vertex. That's the next part. Now, let's go on to the next one, which is y is equal to, okay, label the y and x-intercept, so we'll do exactly that. So we'll go to our graphing calculator again. I'll go back and forth. So we'll enter our equation, okay, the first one. Now, do not remove your y2 equals 0 because we'll use it again to find our x-intercepts, if there's one. Okay, sometimes there's none. So for them, negative, oops. Sorry, I'll clear this here. It's your negative button, which is here, negative 2.65 x squared plus 3.9 x plus 12 and graph. Notice this graph is going down. But I'm not seeing my maximum point here. The top part is, my window is restricted. So I need to go to my window button and increase, notice what I want to increase my y maximum because it's going much higher than positive 10 on the y-axis. So change my y maximum to maybe 20. Just guess an estimate. And there you can see a complete graph. So notice now the y-intercept is approximately, well, it's 12 because from our equation we can tell, but not all the time. In this case, it's 12. Now our x-intercepts, we can just do an estimate right now. So it's between -1 and 2, and here closer to 3. So we can start leaving with 1, 2, 3. So -3 here. 1, 2, 3, 4, 5. So -1, -2. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10. And then the same thing at the bottom here. -5. You don't have to have a complete scale. As long as you indicate the first one, what the scale is 1 here, 2, that's sufficient. Now we need to find the y-intercept. So remember function second trace, press enter, x is 0, y is 12. So we know right away that this graph goes through a 12. Then we need to find the x-intercept, so we're going to indicate here that's 12. Here's my y-intercept. Now I need to find my x-intercepts here, 2. You notice, so I press. Now I already have my y equals 0 button. I'm sorry, equation completed. And second trace, go to intersect. I'm going to find my, now I could go to my right side first. Doesn't matter which one. So I press my right arrow key to move over to the right side. Press enter 3 times. And it gives me a value of 2.99, which is pretty close, right? So 2.9, close to 3. So I'm going to put here an arrow, 2.99, close to 3. And on the left side of the origin, so I want to go check and trace, back to intersect, and I move my cursor over by pressing my left arrow key. And press enter 3 times, and it's 1.5. So 1.52. Okay, so 1.52 is pretty close. So it's between 1 and 2, so it's about here. Negative 1.52. So now I'll sketch my graph. Now it goes up a little bit here, comes down, and opening those downwards. So these are my intercepts. And this graph is going down. So we can see the domain here. This one is negative infinity to infinity. Or you can write this x, such that x is element of real numbers, or a shortcut. Now with Desmos, that's what's going here. You're going to enter your equation, y equals negative 2.65 x squared. Remember, press your x button and the a to the power 2 plus 3.9 x, so your x button, plus, and you press 12. 1, 2. There's my equation. Now I need to see my graph a little bit more. And once you tap down that chevron, as they call it, you tap this down, you will get your graph. And now you find your, this is your y-intercept, 0, 12, your x-intercepts, you tap. Far much quicker with Desmos, less step. And the graph is going down. So that's what's indicated negative. So remember, refer to your sheets here. Now your next page, looking at, now we've looked at what the graph looks like. And so far we've seen these two graphs. This one is going up. Zoom in here a little bit here. So in the first case, this graph is going up. The leading coefficient, as we call it, here's one here. It's one right in front, but it's not written, it's understood. It's positive. So if the graph is, or the A is positive, so remember your general equation of a quadratic, bx plus c. So the b with 2.25, the a is 1, and the c is negative 7.88. If the a is positive, then the graph goes up. If the a is negative, in this case, negative 2 is indicated here, it's going down. Now, but the graph is changing direction. At the point where it changes direction, it's called the vertex. So let's look at your notes here. One of the other characteristics of a quadratic is the vertex. So the vertex of the parabola is the point where the direction of the graph turns, something called a turning point. So this is a turning point here. If the graph is going up, the turning point is the lowest point, or we say it's the minimum point. If it's going down, the turning point is the maximum point. It's located, so vertex. Now, if you were to draw a vertical line through the vertex, you see a perfect symmetry. In other words, the right side of this axis, called the axis of symmetry, the right side of the axis of symmetry is exactly as the left side of the axis of symmetry. If you would go right across here, and you will find out the axis of symmetry is the x-coordinate of the vertex. In this case here, the vertex It's 5, 0. So 5, 0 is a vertex. So the axis of symmetry would be 5. Here it's -2, 4. So -2, 4. The axis of symmetry is -2 because that's the vertical line that divides the parabola or the quadratic function into identical parts. Same as here, we have another vertex, which is a vertical line through it. If at this point is negative, this is 3, 1, 2, so we 3, 2. So the axis of symmetry is 3. Now, the y value gives you the maximum or the minimum. If it's going down, that's your maximum, which is 2. Because along here, this is the axis 2. That's the maximum value. Here, your maximum is 4, because on the y-axis. Here's a minimum is 0. So your vertex is extremely critical. It gives you important information about the maximum value and the minimum value. So going up gives you the minimum value. Going down, the vertex gives you your maximum value. Let's look at some examples here. Now, here we have the vertex at -2, 0. So at this point here, the vertex, the minimum point here, it's y is equal to 0. So at this point here, the graph doesn't go below 0. So we can say the range is from 0 all the way to positive infinity. Now it includes 0. When you put a square bracket like that, it means it includes it. So this includes whatever value you are beginning with. If it's a curved bracket, it means it doesn't include it. Like this is infinity now. This goes to infinity, and infinity is indicated with these arrowheads. If there's an arrowhead, it means it goes on to infinity. If there's no arrowhead, in other words, you may have, if you this graph and it stops like that, if there's a shaded circle, it means it touches it. Now you'll see later on, if you have an open circle, it means it ends there, but doesn't touch that number. So in that case, we write a curve like that. If it touches it, it's blocked in and it's a square. So we'll look at this later on. So in this case, and by the way, whenever you're indicating your coordinates, use these smooth brackets. Do not use a square one. The square one indicates range or domain. In this case, looking at the range is from 0 to infinity. Your domain now, there's no restriction. This arrowhead means it's going to the left forever and to the right forever. So negative infinity to positive infinity, or all the real numbers. Or negative infinity to positive infinity. Let's look at the next one here. The vertex is right here, and at this point here, it is 4, and this is -6 here. So your domain now is all the real numbers because it's going left to right, but the range is from -6 to infinity, including -6. By the way, if it didn't touch 6, -6 here, you would have seen something like that, but that's not the case here. Here, it touches it, so we say -6 to infinity. The last two, here we have, now these graphs, these parabolas are going up, so therefore you'll have a range, there's a minimum. So you have a minimum value. Your minimum value is the y value of your vertex. Now, if the graph is going down, it has a maximum value. So we can see the minimum value here, if you want to write it down there, the minimum is y equals 0. Minimum is y is equal to -6. In this case here, we have a maximum, And the maximum is where y is equal to, in this case, would be 10. So this is your maximum in this case. Here is your minimum. So you're going. So the vertex is 0, 10. Your domain is all the real numbers. But your range now is from negative infinity. Notice how it's written. So you're not going from 10 downwards. You're going from down coming up. Always you're going from the lower to the higher. Lower to the higher. Even though this pointing arrowhead is downwards, this arrowhead is still telling you that it's going to the right forever. It's going to the left forever. That's all this thing. It's your domain. So your range now is from negative infinity, which is way below here. So negative infinity to 10, including 10. The next one, your vertex is 2, 5. So we have that here. And by the way, your axis symmetry is right down the middle, which is your 2, 5, which is x equal 2. So if you were to write your axis of symmetry, you say x is equal to 5 as your axis of symmetry. The domain now, your range now is from negative infinity to 5. So this is your, so negative infinity to 5 is your range. So let's look at our example in analyzing function. Now you're given a graph. In this case, we don't need a calculator. Right. So here we have a graph going up. So we know this is a positive graph, is going up. But it asks us to find the vertex. Now, the vertex in this case is the minimum point here, which is 5, and this is 1. So vertex is 5, 1. So we'll indicate that here is 5, 1. The domain, because this graph, the arrowhead is here indicating it's going to the left and going to the right. So we say x set of real numbers. The range now is from 1 going up to infinity. So this is my, so 1 square bracket to infinity square bracket. Vertex here is 5, 4. So we know, there we go. So it's going down. So let's write a vertex here is 5, 4. The domain now is from all the real numbers. The range now is from negative infinity to 4. So we say negative infinity, small bracket, to 4, close bracket. Putting all of this together, this is what we'll end up with here, what it'll look like. So you're given a graph in this lesson, and you ask the shape. If it's going up, you say it's moving upwards. Now, if the graph is going down, if it was a graph going, let's say this one we have here, then we say the graph is going downwards. So if it was going down, we say the shape is the parabola opening downward. And the end behavior now, okay, this is going up. Now the leading coefficient is positive, so the leading coefficient is here to be negative. So this is going to be ax squared plus bx plus c. So the leading coefficient is positive, and the number in front of the x squared is positive. In this case here, this is negative x squared plus bx plus c. The leading coefficient here is negative. Now in quadrant, this is your third quadrant, your fourth quadrant, quadrant 1, and quadrant 2. So remember going counterclockwise from 1. So we go from quadrant 2 to 1. Notice, right, you're not saying going from 1 to 2, right? Then the reason for that is that using increasing x and what's happening to the y value. So you're going from left to right. So you're going from 2 to 1, because as the x increases, what is happening to the y? It decreases and increases. So we say it's from quadrant 2 to 1. The y-intercept, where it crosses the y-axis here, in this case is 0. The x-intercepts are -4 and 0. The vertex right here, which gives it -2, 4. Okay. The value of the minimum is your y value for your vertex. There's no maximum value because the graph is going up. Notice there will be a maximum value for the graph going down. The domain will be all of the values in the x-axis. But the range is from your minimum, which is -4, to infinity. So let's look at 2 other examples, and which is on the next page. Go through this very quickly. And so we're going to use this vocabulary here. So we're going to keep this handy. Okay, so let's set myself here. Okay, let's zoom out a little bit. Sort of have this handy beside so you can see the comparison. So this, I'm trying to get this here. Make sure it's center this guy. So in this case here, we see your graph y. By the way, you could enter this into your graphing calculator, and we'll have to do it eventually. Oh, that's the wrong one. Oh, here we go. Sorry. I thought I'm the wrong. That's our next lesson. We'll be entering the graph. In this case here, the graph is given. Okay. So here's your graph is given. Direction, we're going to say it's opening upwards. It's very similar to the one we have here earlier, somewhat identical. So use this model in the previous example. Oops, I'm using the wrong one. Okay, sorry. I'm doing the assignment question. I apologize for that. I need to get to this guy here. So here we go. Example 2. So direction, in this case, is going downwards. So the shape of the parabola. So the parabola is spelled parabola, but it's pronounced parabola. Opening downwards. Sign of a leading coefficient. Now, because it's going down, it's negative. The end behavior is from quadrant 3 to quadrant 4. The y-intercept would be 6 here. be 6. You can put your 0, 6 as your. The x-intercepts are -2 and 6. The vertex, this point right here, which is 2, 7. Which is 2, 8. Let's see here. 6, 7, oh, 2, 8. Oops. This is my intercept here. I need 8. 0.28, let's see, 6, 7, yes, right here. Minimum value, there's none because it goes down to infinity. Maximum value is your y coordinate for your vertex, which is 8. The domain would be all the real numbers, or it is infinity to infinity. And the range now is from -infinity going all the way up to 8. Oops. And including 8. Another way you'll see when you get into see some of the books, we write it as y, which is called infinite, such that y is less than or equal to 8, where y is an element of real numbers. This is called interval notation, but you don't have to worry about this yet. The next one is identical to the example we just did in the previous page. Direction, it's opening upwards. So we can do that. My center of a leading coefficient would be positive. The end behavior, so it's from quadrant 2 to quadrant 1. The y-intercept, that'd be 6, 7, 8. Okay, or 0. The x-intercept, there's only one actually, which is the vertex in this case. This x-intercept is 4. Or 4, 0. The vertex is 4, 0. The minimum value here is the y value for your vertex, which is 0. Right, minimum value here. The maximum value is none because this goes to infinity. Domain is x instead of real numbers, or -infinity to infinity. But the range now is from 0 going to infinity, including 0. So your task now is to complete assignment 1. Which is on page 8, complete assignment 1. So today, our main goal is to describe the characteristics of a quadratic function when you're given the graph. We define what a quadratic function is, then we sketch It's quadratic function, finding the x-intercept and the y-intercept for 2. Then we look at the characteristics of the function, quadratic function, in terms of the shape, leading coefficient, and behavior, y-intercepts, x-intercept, vertex, minimum value or maximum value, domain and range. And your assignment is assignment 1 on page 8. Next lesson, we'll be looking at quadratic function when you're given the equation.